All right, my clock is showing 11, so I think we can get started. So thanks everyone for joining us today for our biweekly free Friday webinars. Today's webinar is on horizontal and vertical curves in county road design. We'll be recording today's presentation so you can pass it on to anyone who missed the presentation or watched it again if you feel so inclined. There's also a question panel where you can type in any questions. We'll keep our eyes on the panel and answer any questions throughout the presentation. So just before we get started, a quick introduction about who we are. Softtree's been designing civil design software for over 25 years, and our philosophy is to keep our software very easy to learn and use. We really try to stay away from the steep learning curves that often exist in the civil design software industry. So hopefully that will ring true today as Jack shows you how to easily design horizontal and vertical curves. Just a quick outline of what we're going to be covering today. Jack will be covering designing horizontal curves as well as vertical curves. He'll be showing you both basic and advanced functions in the curve panels. And at the end, he will show you a 3D drive-through, which can help you to visualize how the curves will look once there's. Today's demonstration will be done in RoadEng. So for those of you who are not familiar with RoadEng, we will be using two modules of the program today, the terrain module and location module, mostly the location module for designing the curves. And before I pass things on to Jack, here's a list of our upcoming webinars. Got a few listed there into January, so please sign up for any or all of them. We'd love to see you again. With that, I will pass things on to Jack.
Thanks, Kim. Just gonna, could you, thank you.
Yep.
And thanks again for joining us, everybody. I'm going to start with the location design module. The topic today is basically just about horizontal vertical curves, so I'm not going to actually create a tin model, but there is a background, a contour file tin model, a topo surface that the design is being done on. And there's already been a horizontal alignment and a vertical alignment placed on the, so we got a horizontal alignment, horizontal IPs. Vertical alignment has been already done for us, for me. I'm going to start with the horizontal. I'm not going to talk about templates, but there is a template already in here. It's just a simple two-lane highway metric design for all of our friends in the United States, which is probably not very many at this time because of Thanksgiving. We do, you can put in, everything is metric for this design, but you can put in imperial templates and also design based on feet and in miles per hour for your horizontal and your vertical curves. Going to get our screen layout here for horizontal alignment. Start talking about horizontal curves. I'll start in simple mode and then go on to advanced functionality. Use these buttons here to jump from IP to IP or PI to PI, intersection points. I'm going to put in a circular curve of 250 meter radius. And I'm going to start with no super elevation at all. The transition length doesn't matter right now because I have no super. If I did have a super, the transition length is the transition from no super to full super. And the transition fraction is, where does this transition occur? If it's 0.5, it would occur, half of the transition would occur, of 80 meters in this case, would occur outside of the curve, and half of the transition would occur inside of the curve to full super. There's also widening. This is mostly used for forestry cases. You can add extra widening on the inside, outside, or both. I'm not going to be dealing with widening, but just be aware that you can apply widening, and you can also have the software put in automatic widening for you based on a table. We do have tables built into the software. They're all right here. There's a super elevation table. There's a max side friction table, a transition length table, and a widening table. Right now I'm in simple curve mode. If I decide to go to advanced curve mode, all these tables will unlock for me to edit them. And to edit a table, you go into the, let me just go back in there again. To edit a table, you click on this button here. You can change the super. These are all just simple text tables. You can just open up in a text editor and modify them. And the way the tables are read is we got design speed across the top. We got radius along the first column. And it's just a simple lookup table. The software just takes the design speed and the radius, for instance, and looks up the appropriate super, which in this case is in percent. Going back to the table, we also have other tables, max side friction. This is the friction required to keep the vehicle on the road. The higher the side friction, the less likely the more likely the vehicle will skid off the road. The lower the side friction, the more likely the vehicle will stay on the road. So basically that's why we, at 120 kilometers per hour, you are more likely to skid off the road. I said that wrong. The lower the side friction, the more likely you are to skid off the road. And the higher the side friction, the less likely you are to skid off the road. And traction will be maintained on your vehicle between the tires and the road surface. Let me just talk a little bit more about this table, this panel while I'm here, or this dialog box. You can set up any of these specifications, your desired design speed, your reaction time, your eye height, your object height, minimum radius, minimum sag K, minimum crest K. This is all based on mathematics, so this is just numbers that are always in there, acceleration, deceleration. You can put in your max grade and min grade and your max super elevation. All those numbers can be just typed in by you. And then you can save them all as a table in the table. Let me just assign a curve. Let me go back to simple curves first. And I'm going to assign curves of a specific radius. I'm going to get a default curve, which is 200 meter radius. 6% super. Transition length is 80, and I'm going to do half of my transition is going to occur outside of the curve, and half of the transition is going to occur inside the curve, so 0.5. Normally, for people that are designing county roads in the States, are using 2/3 transition outside, 1/3 transition inside. So that's what the normal transition would be for a horizontal curve. But I'm just going to keep it at half just because it's easier to take a look at what's going on in the horizontal plan window and also the section window. Apply that curve. Set that as my default. Jump forward. Get my default. Let me just show you one thing before I actually apply that curve. Let me just move the IP somewhere out here. Get my default. If you see this message, that means that there's an IP or a curve in the way. You cannot fit that curve. So to be able to fit the curve, you should try to move the IP out of the way of that other curve or the other IP. Now I can get my default and apply that.
Jack, did you see the question there about spiral curves?
Yeah, we will talk about spiral curves. I just want to talk about circular curves right now. I'll talk about spiral curves in a sec.
All right. Well, thanks, Maurice, for the question. We'll answer it shortly.
No worries. Yeah. No worries. Yeah, in simple mode, you don't have the spiral capability, but when you're in advanced mode, you will have that spiral capability. I'm just going to talk about simple curves for now. Talk a little bit about these little green marks that you see here. This is where all the transitions are occurring. So at this point, we are at full transition, full super, sorry. And then if I go back towards the start of the curve, at this point, we are at the 1/3 point. And then at this point, we are at half, so 3% super, so on and so forth. If the curves are actually touching, so if we go into an S curve, let me just move that over. You won't actually go into at the point where the curves touch, you won't actually go back to crown. You'll only go back to flat. I obviously don't have my curves touching, so I'm just going to move a little bit more over. Yeah, we got 0% super right at that interface of the two curves. All right, advanced mode. Click on the button, this button again right here. Turn off simple curves. So now to answer that, while I'm here to answer that gentleman's question, we do have spiral curve capability. And you can type in a tangent length, or sorry, tangent runout length. You can type it in, or you can get it from a table. Let me just set my minimum curve radius and I'm going to set it up so that it's an 80 mile per hour or kilometer per hour road. I'm going to pull up my curve so that I'm not touching anymore, so I can fit an 80 kilometer per hour road. That's going to change the radius to 250. Again, it's going to that lookup table. And to answer Maurice's question, yes, you do now have the transition length for spiral and also the tangent runout length percentage. Let me just apply that curve. And the length is going to be 80 based on, since we're in Canada, based on TAC tables. If you were in the United States, everything would be based on AASHTO tables. So we do have a 6% super. Again, it's looking at that lookup table to get that 6% super. We got an 80 kilometer per hour road and a 250 meter radius. So all it does is go down the lookup table and find the appropriate super, which is 0.06, which is 6%. Let's go back to change this curve so it's a little bit farther away and try to put in that spiral again. I seem to not be able to do that, but I'm going to move things away from each other. I'm going to change my design speed to something less. Spiral fits. So now we're at 190. And then set that as my default curve. Jump forward. Get my default curve. Apply. Spiral is a much larger curve. You can see that there's different runouts, transitions for a spiral to fit. So yes, to that gentleman that asked the question, yes, you can do spirals. Let me just go back to simple circular curves. Change my radius to, change my design speed to 80. Move my curve away from each other, or my two IPs away from each other. Set that as my new default. Jump, get my default, apply. So now we've got two circular curves. Move them closer to each other, making them S curves if at all possible. So now we have the different transitions that I was talking about at the beginning. Just a little bit more about this dialog box before I go into vertical curves. You can change, I've seen a lot of people do this. You can type in your IPs based on coordinates if you want to, or you can go into modifying coordinates based on azimuth and distance and stationing and delta X and Y. So simple coordinate geometry, simple COGO. You can use simple COGO in our software to type in all that information. I'm going to leave the, actually one more thing before I go on to vertical curves. I'm going to turn off my minimum radius and just show you what happens to the super as I no, I'm gonna leave it at that. I'm gonna go on to vertical curves. So again, this is 6% super elevation and 190 meter road. Let's go on to vertical. I'm going to get a screen layout for vertical curves and vertical design. Again, like I said before, I've got design points in here. Let me put in 70 km/h. Let me start simply again before I actually go into advanced mode. I've got some of my horizontal alignment falling off the edge. Let me just go and see what's going on. Oh, it's over here. Yeah. All right, simple mode. Start out with simple mode and then go to more advanced mode. Simple mode is just simple K value or length of curve. K value is the percent change in grade divided into the length of curve. For a 80 km/h road, a K value of 30 is appropriate. And that would give me a length of 86.1. So the software already calculates the change in grade, the grade after minus the grade before. So the grade after minus a minus would be a positive, dividing that into the 86.1 length, and that would give me approximately a 30K road. Apply that curve. I can also type in, I can also lock my, instead of having a lock K, I can have a lock L. So if I want a specific length curve, that would automatically back calculate the K value. Let me go back to no curve and just show you again that message that we see if I move these two close together and I get my default curve. There's that message again that we saw in the horizontal curve panel. Curve does not fit tangents, and that's simply alleviated by moving one IP or curve away from the other and then trying to apply your curve. We also have simple coordinate geometry. Again, you can type in your station, your grade before, grade break, horizontal distance. I'm just going to show you one thing here. I'm going to show you how to change the elevation in here. You can change the elevation of your IP. Let me just change it to 363 and apply. Notice how that moved down. Let's go back to 360, 365, can't fit. Let's try 364. That one can't fit either. Let's go 363.5. That fits. There, we're back up. You can also change the station of that IP or PI. Advanced mode. Now we have design speed included in the scenario. You can also, like I said before, in the horizontal, you can type in your design speed, and it will calculate your K value, your length, and your site stopping distance. This is the distance that's calculated from all those, all these driver limitations and also vehicle limitations to get your site stopping distance. If you want to have a little bit increased safety on that site stopping distance, let me just change this to 80 and apply, and then that's the minimum site stopping distance. So let's say we up that to 135. That will give me a little or factor of safety. Set that as my default curve, jump forward, get my default curve, apply. One more thing I'd like to show you, as Cam said, I'd like to show you a drive-through. Let me minimize this curve panel here. Show you, first of all, before I go to the drive-through, let me show you how to balance this road a little bit more. Pull this IP down a bit more. Try to get rid of some of this borrow going on. So all you do is grab your IPs and pull them down or up. If you see too much red, that means you got cut. Pull it up if you got too much cut. I could probably put another IP in here just to get rid of some of that cut that I have going on here. And then obviously I'd get another, get my default curve and apply that there. So now I'm pretty well balanced. I got a little bit too much borrow here. The other colors that you see here are free haul, overhaul, and of course the red you saw before was waste and the blue was borrow. I got a little bit too much borrow here. Let me put another curve IP here. Pull that down. Get my default curve. Apply. Try to balance that out a bit more. Okay, let's go on to drive-through mode. I'm going to save this as, let me just see which codes I'm going to save out. ST2L, ST2R, and CL3. File, save as, save it as a train file, metric designed. Get all my codes, remove all these, add S3L3. Hold my control key down to select all the others in the list. Road edge left, road edge right. ST2L, ST2R. Side slope left, side slope right. Press the add button. And then select all of these in the list. Make sure that you get them all. Go back at the top and just click and drag all the way to the bottom and make sure that they're brake line features. Add some extra points so that the drive-through is a little bit smoother. 5-meter intervals is good enough. Go to my original topography, edit external files, edit external files, edit external files, open up that topography, merge, turn off a couple of these options, browse for metric design, and there it is. Just going to there is one feature here that I don't need. I'm going to delete it. I forgot to not export it. Generate my tin and contour. So basically what the software did was create a hole in this area, get rid of all the data for the topography in this area, generate my contours again, and then drive through. Window, new window. No, I don't need a new window. Just right click, active window 3D options. No, right click, drive through flyby. Play. Increase the rate. at the end. And if you want to go back in the other direction, it's a nice presentation tool. So once you've done your design, you can present this to all of the decision makers. Well, thank you very much. That's all I wanted to show you today. Thank you.
Have a good weekend, everybody.
Yeah, and join us for our future webinars. Thank you, folks. Bye-bye.